Hey guys, this is Miss Pasquale, or you know me as Sensei. I will be working. What was I working on? I will be working on test number 11 review, pages 2 and 3. Miss Bettis has already uploaded pages 1 and 4. Your test is this Friday, March 28th, and therefore this review is going to be due Friday, March 28th. So I commend you for watching this video because by watching this video, you are completing this review. Alright, so let's begin. So number 6 states the area of a rectangle is represented by the expression x squared plus 16x plus 55. If the width of the rectangle is x plus 5, what is the length? Area of a rectangle is represented by length times width. Here's a trick. If this is the area, well, let's write it out here. X squared plus 16x plus 55. Let's go ahead and factor this. When we factor, we can use the AC method. So A would be 1 because that's the coefficient of x squared. B will be 16, that's the coefficient of x. And C will be 55, that's the naked number. Now that I've identified my A, B, and C values, I'm going to start trying to find out my factors. So A times C, 1 times 55 is 55, and my B value is 16. Basically, whenever you're factoring, you want to find two factors that multiply to give you 55, or your A times C, and those same two factors add up to your B value, and in this case, it's 16. And when you actually explore the numbers, 11 and 5 work. 11 times 5 does give you 55, and 11 plus 5 does give you 16. So it's kind of like finding puzzle pieces. Let's transfer this down into our two binomials. This is x, positive 11, so x plus 11, and this is x, and a positive 5, so x plus 5. Let's reorganize the information that we have so far. I've rewritten my area like this. I didn't change the value, I just changed the way it appeared. In my formula, area equals length times width. If my width is x plus 5, and my area is x plus 11 times x plus 5, I want to find something. So my length, I want to find what my length is. What do I multiply x plus 5 by to get x plus 11 times x plus 5? Well, obviously, what you multiply x plus 5 by would be x plus 11. The expression for the length would just simply be x plus 11. Number 7 gives us a table. How can you determine whether a table represents a quadratic relationship? In a quadratic, we know it's going to be some sort of U shape, whether opening up or opening down. So there's going to be values that repeat along the y-axis. All you have to do is look along the y column. Do you see any mirrors or any repeats? Well, yeah. 2 and 2, 1 and 1, negative 2 and negative 2, and negative 7 and negative 7. It mirrors. Therefore, and by it mirroring, remember, this refers to the y values. On number 8, we have a graph. The graph shows the height of an object thrown from a bridge. What is a reasonable range for the graph? Well, range represents your y values. And in your y values, you scan the graph from bottom to top. From bottom to top, what is your minimum value? Well, your minimum value of the y's is 0. So obviously, I can cross out C and B. They have my minimum values being 68 or 50. Also, you can cross out A because it says x values, when obviously range is your y values. All that's left is D. You could even check. It goes from 0 and the highest point is somewhere up here. That's when y is approximately 68. Number 9 states the graph of a quadratic function is shown below. Ta-da! What is the negative value of x for which this function equals 8? So if a function, so let's say whatever function this is equal to 8, f of x is the same thing as y, isn't it? So I want to find when y is equal to 8. Y equals 8, that's a horizontal line somewhere that looks like this. Y is equal to 8, 2 points in my graph at negative 3, 8, and 7, 8. But the question is asking what is the negative value? Well, my negative value would be negative 3. So you just say negative 3. I'm going to bubble in the negative and then bubble in the 3. I like cheese. And we love math. It's so awesome and fun. Yay.
Lindsay threw a ball upward from the roof of a 50-foot high building at an
That's enough,
initial
Mickey Mouse.
No!
Let me do the math. If the height of the ball is a quadratic function of time, between what times did the ball reach a height of 52? Here's the ball. She dropped it off of the roof, so it kind of went up and then it went down again. This is a 50-foot tall building, and we want to find it when it had a height of 52 feet. So there's going to be 2 times when it's at 52 feet. Thing with the initial velocity, irrelevant. Y represents the height in feet. As we can see, it starts off at the roof at 50 feet. And then it goes up, up, and then it goes down again. Just like in our picture. Between what times did the ball reach a height of 52 feet? Well, let's look where 52 feet may be. Well, between 50 and 66, yeah. 52 feet is somewhere in between 50 and 66 feet. Same thing here. It's in between 66 and 50. So in between what 2 times? In between 0 and 0.5, and in between 2 and 2.5. So option 1 says between 0 seconds and 0.5 seconds. Well, yeah, that must be correct, because that's what we stated here. Option 2 says between 1 second and 1.5 seconds. Well, obviously not. And option 3 says in between 2 seconds and 2.5 seconds. Well, yeah. So your answers are 1 and 3. 1 and 3 only. Letter D. Graph, plot, new function. For the next couple of problems, you're going to have to be familiar with different types of transformations in regards to quadratics. Remember, your standard form of your quadratic is ax squared plus bx plus c. But in Algebra 1, we don't really worry about the transformations of the b parameter. So instead, I just cut it down to ax squared plus c. So a and c are numbers. So let's see what happens if I change the a value. As I increase my a value compared to the parent function, it gets more and more narrow. And as I decrease it in between 0 and 1, it gets wider than the parent function. And if it becomes a negative, it flips. So in regards to changing the c value, let's move the c value up. Whenever I increase my c value, or c is a positive number, it shifts the graph upward. And as the c becomes a negative value, it shifts the graph downward from the parent function. Looking at number 11, if the graph of a function in the form y equals ax squared plus c has a vertex located below the origin and opens upward, what must be true about the values of a and c? So if a is a positive number, that means a is greater than 0. And if c is a negative number, c is less than 0. So the one that matches is letter C. So for number 12, it states write the equation of a parabola that is narrower than the parent function. In regards to being narrow, we're only dealing with the a value. As we increase the a values, it becomes more narrow, whether positive or negative. Y equals 1x squared. This is my parent function for the quadratic. So in order for something to be narrower than the parent function, all I need is a number, the absolute value of some number, being greater than 1. So I can have y equals 2x squared. And that's a function that is narrower than the parent function. Number 13 states, write the equation for a parabola that is wider than the parent function. Well, remember, for it to be wider than the parent function, it had to be in between 0 and 1. I can use y equals 1/8 x squared. The only thing that matters is that it needs to be wider than the parent function. And that 1/8 as in place of a does that for you. Again, you can have multiple answers. There are infinitely many answers to these two questions. Number 14 states, write an equation for a parabola that is congruent to the parent function but shifted 3 units above it. I want the parent function y equals x squared but shifted up 3 units. Whether shifting up or down, that's affecting the c value. All you have to do is add 3 to the end of it. Your function would be y equals x squared plus 3. To illustrate that, here's my equation. I'm going to change it so that my c value, or whatever we add here, is 3. And yeah, it is your parent function shifted up 3 units. Number 15 states the graph of y equals 22x squared plus c is a parabola with a vertex at the origin. Well, where's the origin? Oh, it's at 0, 0. What must be true about the value of c? Well, if c affected whether it moved up or down from the origin, well, the value of c, if it's at the origin, c must be equal to 0. Because if c is equal to 0, that means you neither shifted up nor down. Your graph is still at the origin. And it doesn't matter like, oh, what about this 22? Oh, that just affects whether it's narrower or wider. So c must be equal to 0. Number 16 states, what is the vertex of the graph of the quadratic function f of x is equal to x squared minus 2x plus 5? Well, remember, guys, vertex in any parabola, whether opening up or opening down, it's either the minimum point or the maximum point. So there are multiple ways that you can go about finding this. Let's just go the easy route and use our calculator. They give you a function, well, might as well graph it. Go to your y equals, and we're going to plug that in.
X squared minus 2x plus 5.
So our graph looks something like this. Let's go to our table. Second, and then graph. That will bring you to your table. To find the vertex and even the zeros, you look at the y column. Notice how it's mirroring 5 and 5, 8 and 8, 13 and 13. Well, whatever's in the middle, that's your vertex. Because the vertex occurs where your graph changes direction. It's decreasing and all of a sudden it's increasing. So wherever it is in the center, that's going to be 1, 4. Number 17 states, what is the solution set to the equation x squared minus 2x minus 35 equals 0? Solution set meaning x equals something and x equals something. So don't be thrown off by these brackets. These brackets don't imply ordered pairs. This just means x is this value and x is this value. So whenever you're solving equations or solving quadratic equations, you're actually finding your roots, your x-intercepts, your zeros, your solutions. Basically where your graph crosses the x-axis. So there are multiple ways that we went about finding this. You could factor, you can use the quadratic formula, and you can even use your calculator, which is probably the best bet or the easiest method. So let's just go ahead and use our calculator.
So it's x squared minus 2x minus 35.
You can see that, yeah, my parabola crosses the x-axis in 2 different spots. So if it's kind of hard to see on the graph, you can go to your table and scroll and see when y is equal to 0. And hey, here's one. It's at negative 5. Scroll up. Here's another one. It's at 7. So pretty much x is negative 5 and x is 7. Number 18 states, what are the x-intercepts of the graph of the quadratic function f of x is equal to 12x squared plus 42x minus 24? Well, the easiest way again is just to use your graphing calculator. So I just plugged that into my y equals, and I'm going to look at the graph. Well, it crosses the x-axis at 2 different places. That's my x-intercepts. So you can just go ahead and find them using the second trace function. And let's go to our 0, because remember, x-intercepts, that's the same thing as roots, otherwise known as your solutions, also known as your zeros. I'm going to scroll somewhere to the left of my first one. It's going to take a while for it to show. Oh, there it is. Somewhere to the left of this first one. And I'm going to press enter. Now it's going to ask for the right bound. I'm going to scroll to the right of it. That's technically to the right of it. I'm going to press enter twice. And my first one, my first solution, my first x-intercept is at negative 4, 0. Now let's do the same thing for this one right here. Go to second trace, and it's the second option, 0. I have to scroll somewhere to the left of it. Okay, there it is. Press enter, and then scroll somewhere to the right of it, and press enter twice. And it is at 0.5, 0. And those are your x-intercepts of that function. So moving on to number 19. Number 19 states, which expression is equivalent to 2x squared plus 17x minus 84? Here I have answer choices. The easiest way, because our a value is not 1, is just to, well, FOIL these out and check to see which one matches. So looking at option A, let's go ahead and FOIL this out. F is for first. I have 2x and x. Those are my first terms. 2x times x. That gives me 2x times x is 2x squared. So O is for outer. my outer terms are 2x and 4. So 2x times 4. Well, 2x times 4 gives you 8x. I is for inner. Negative 21 and x are my inner terms. So I have negative 21 times x, which is simply negative 21x. For last, my last terms are negative 21 and a positive 4. Negative 21 and a positive 4. We'll multiply together, give you a negative 84. All of these I want to add together, but oi! Combine like terms. 8x minus 21x is negative 13x. So all you have left are this, plus this, plus this, because those are as far as you can simplify it. So your expression was 2x squared minus 13x minus 84. Does that match the first one? Well, no. Option B.
Now we have to FOIL out option B. 2x minus 7 times x plus 12.
First, outer, inner, last. I've got to FOIL. First terms are 2x and x. 2x times x. Well, what does that give you? That gives you 2x squared. O is for outer. Your outer terms are 2x and 12. 2x times 12 gives you 24x. I is for inner. Negative 7 and x are your inner terms. Negative 7 times x. Well, what does that give you? That gives you negative 7x. L is for last. Your last terms are negative 7 and a positive 12. Negative 7 times a positive 12. Well, that gives you negative 84. Oi! Combine like terms. 24x minus 7x gives you 17x. These three terms added together, that's as far as I can simplify. That would be 2x squared plus 17x minus 84. And as you can see, hey, it matches. So my answer is option B. Number 20 states, what are the zeros of the quadratic function? Remember, zeros, that's the same thing as your roots or your x-intercepts or your solutions. Whatever, they're interchangeable here. So again, whenever we're trying to find the x-intercepts, we have multiple methods. Graphing, table, factoring, quadratic formula. I'm tired, so we're going to use the graphing calculator.
Plug it in 3x squared minus 5x minus 2.
Well, yeah, I can see it crosses in two different places. Somewhere in the negative and somewhere in the positive. Go to second trace, and we want to find our zero. So, option 2. So let's find this first one over here on the left side, where it crosses the x-axis. Left bound somewhere to the left is up here. Press enter. Somewhere to the right is down here. Press enter twice. It's about negative 0.33333 repeating, which is the same thing as negative 1/3. So negative 1/3 is the first one.
Before you even find that out, just take a quick look at your answer choices.
Ooh, looky guys. Test taking strategy. This doesn't have negative 1/3. This doesn't have negative 1/3. And this doesn't have negative 1/3. The only other option would be C. And if we were to try to find it, left bound, enter. Right bound, enter, enter. Yeah, it is 2. So the next part, the back part, the writing part, yay, writing, not really, would be done by Miss Elizondo, and her video is also up. There once was a negative boy who couldn't make up his mind about attending this radical party. He was a square boy who missed out on the chance to chill with 4 awesome chicks. And it was all over by 2 a.m.